Boy, just when you thought you had all those numbers figured out, then they throw in some more numbers. Anyway, let's, I don't know. What color are we using today? Purple? Green? I need to use a different color. I want to start with this right here. This is where we're going to start. Trying to figure out where I need to put the microphone. Okay, we're going to start right here. So what's going to go on here is we're going to circulate back around to solving quadratic equations. And we worked a problem earlier that had a funky solution to it that you may have not ever seen. But I'm going to write an equation. And there it is. Now, we want to find the solution to this equation. Well, it turns out that there's not a real number. Think of the real numbers as this. Now, I know I haven't talked about, all the different kinds of numbers. But think of this is the real number line right here. Think of the real number as just every single point on this number line represents a real number. Okay, so pick a point, represents a real number. Right, so for example, this could be 0. That's a real number. Here's another real number, which is an irrational number, square root of 2, and which is like 1.41 something. Pi is in here somewhere. This is a transcendental number. Okay, I know this is not to scale, but pi's in there somewhere. And then, of course, we have our rational numbers like a half. Okay, that'd be all the fractions. These are your rational numbers here. So anyway, just an overview of the real numbers. But there's not a number that we can plug into here such that when we square it, we add 1, we get 0. Well, guess what? That's where this guy comes in, these complex number thingies here. There is a number, by the way, but we're going to have to project ourselves out of the real number line and into some imaginary space. There's a number. Let's go ahead and solve this. For example, let's say we're solving it. So I'm going to take this over here, and then we got this, and oh my gosh, do you know two numbers you can multiply together gives you -1? Now they got to be the same number, right? Well, hold on, we're not done. Let's go ahead and square root both sides. So let's do that. Now, when we square root a square, the square goes away, so we're just left with, and of course, we know the reason why, right? Because we can get this out of radical form, put it in exponential form, raise it to the half power. What do you do with exponents? You multiply them. 2 times a half is 1. Okay, but we don't write it there. Okay, what is that? Is that somewhere on the real number line? No, it's not. It's not. So what happened at some point in time in history, we won't get into it, but you can look it up if you want. Anyway, there was a thing called I, and I is the solution to this equation. And when we plug I in, guess what? It equals 0. Yeah, I'm not kidding. So I squared, okay, I is the actual solution to this equation. Now, so if we did this, I is equal to the square root of -1. I is equal to the square root of -1. Okay? Now, what is a complex? A complex number. What is a complex number? A complex number is a real number plus an imaginary number. Okay? The imaginary number. A complex number is a real number plus an imaginary number. probably going, what? Sometimes we say it's z right here. Okay. So let's look at some complex numbers. All right. We're going to look at some complex numbers here. And we're going to try to write them in a standard form. Now, this is your standard form. You put the real part and then the imaginary part. All right, so let's take a look at this. Let's say we had 2 plus the square root of negative 25. Okay, we want to get it in this form right here with an I. Okay, I'm going to rewrite this as 2 plus. Now, we got to do something with this right here. This is the square root, and I'm going to write negative 1 right here, times, okay, this is 5 squared. We could rewrite that. 25 is 5 squared. We could break this up as 2 plus the square root of negative 1 times the square root of 5 squared. Now, we didn't have to do that, but we did it anyway, because you should know what the square root of 25 is. It's 5. All right. Now we have 2 plus. Now what is this? Remember what this was equal to? This was equal to I times the square root, okay, of 5 squared is just 5. All right. Now, of course, I've got it written up there as bi, so we'll just go ahead and write 5i. All right, see that? The real part, the imaginary part, it's written in standard form. All right, let's take a look at some others here. 5 minus the square root of negative 9 can be rewritten as 5 minus, all right, now remember, this is the square root of 9 times, I'm going to say negative 1, okay? We can break that up as 5 minus the square root of 9 times the square root of negative 1, which equals 5 minus the square root of 9 is 3. And what is this? I. Okay. So 5 minus 3i. All right, let's look at another one here. Okay, what about 1 plus the square root of negative 8? So this can be rewritten as 1 plus the square root. Now, this 8 can be rewritten as 2 times 2 squared times negative 1. Okay, we can break this up as 1 plus. Now, there's a square in here, so when we square root it, we'll just do like this for right now. We're going to break these up. Okay, so this can be rewritten as 1 plus. Can't do anything with that, but the square root of 2 squared is 2, so let's just bring it out front. And what is this? This is I. Okay. All right. Working our way through the list. What about this one? What about that one? What is this? Well, we can break this up as, what can we break this up as? 25 times 2 times negative 1. How's that? Okay. So this becomes, we can split it up. Like such. The square root of 25 is 5. Square roots of 2 times, remember, this is your I. Now you notice in this particular one it doesn't have a real part. Okay, it's just got an imaginary part. That's okay. That's okay. All right, let's take a look at another one here. Ooh, what about this one? Negative 3i plus I squared. So we want to simplify this. Well, there's nothing we can do here, so I'm just going to rewrite. However, I squared, remember what I squared was equal to? Okay, let's just write some side work over here. But if we square both sides, square this side, now we get I squared, then square square goes away. So, whoops, I squared is -1. So this becomes -1. Okay, but we want to write it in standard form, so this is -1 minus 3i. All right, -1 minus 3i. Let's look at another one. We are moving right along. Okay, how about this one? -4. Let's try to get rid of that. We're way up here now. -4i squared plus 3i. Okay, what did this I square represent? Remember? This is what we need to remember. Then we square it. Okay, I squared is equal to -1. Okay, so that's -1. So we have -4 times -1 plus 3i. So negative times a negative is positive, plus 3i. Okay, written in standard form. All right, looking at another one here. What about this one? We just have 3. Well, we could write it. We don't normally, but it can be written like that. Okay, but there it is. All right. Okay, here's a tricky one here. We got all kinds of tricks. How about the square root of -4 and the whole thing is squared minus 3. Okay, so what do we got here? We're going to, well, what happens when you square a square? Goes away, right? You could also write it like this, -4 times, and what is this? This is the square root of -1 times the square root of 4 times, look at this one. Okay, we're breaking it up, we're breaking it down. What is this? This is I. What is this? 2i times 2. What do we have? 2 times 2 is 4. And 4 times I squared. But what is I squared? I squared is, what is I squared? -1, so this becomes -4, right? So let's go back. So we now know what this is. This all actually simplified down to -4 minus 3, which equals -7. Okay. If we wanted to, we could add that, I guess. All right, -7. So that all reduced down to -7. Okay, what time is it? 13 minutes. All right, I think we're going to call it quits on that, and we're going to get into add, subtract, multiplication, and some dividing in the next video. We're moving along. We covered quite a bit there. All right, see you over there. Bye.